Okay, I think everybody can hear me right now. Welcome again to Second International Congress on Ship and Marine Technology. I am Dr.Burak Yıldız. I am the co-chair of this session. In this session, we have 4 presentations, and we will start with a study titled as a study into the economic viability on autonomous shipping, a case study of a 9,400 TEU container vessel, which will be presented by Ivana Jovanović, right? And welcome again. The floor is yours. You can start your presentation. You have 15 minutes to finish your presentation, and after that, if you have any questions, we will also have extra 5 minutes to answer the questions. So you can start.
Okay, thank you very much. My name is Ivana Jovanović, and the title of my presentation is a study into the economic viability of autonomous container shipping, a case study of a 9,400 TEU container vessel. Okay, of course. Just a second. Okay. This presentation consists of introduction, state-of-the-art, cost model, case study, results, and conclusion. Autonomous vehicles are appearing in ever more fields, such as aviation, public transportation, and the automotive sector. That is why it is not unlikely to see the deployment of unmanned merchant ship at some point in time. An autonomous vessel is defined as a vessel with next generation modular control systems and a communication technology that will enable wireless monitoring and control functions both on and off board. This will include advanced decision support systems to provide the capability to operate ships remotely under semi or fully autonomous control. Autonomous maritime vehicles are classified into unmanned underwater vehicles and autonomous surface vehicles. Unmanned underwater vehicles are further divided into remotely operated vehicles and autonomous underwater vehicles. On this picture here, we see an example of autonomous underwater vehicles that is used for oil platform inspections. Autonomous surface vehicles are divided into maritime autonomous surface ships and unmanned surface vehicle. Here is a unmanned surface vehicle that is used as a research platform. Maritime autonomous surface ships is commonly used as autonomous ship, and it is further divided into autonomy assisted bridge, periodically manned bridge, periodically unmanned ship, and continuously unmanned ship. Here is a picture of Yara Birkeland that is a fully autonomous and fully electric ship built in Norway. The driving force for the development of unmanned and autonomous ships lies within the opportunity of cost savings by fuel reduction and lowering operating and voyage costs, safer waterborne transport by eliminating human error that is responsible for more than 60% of maritime accidents, greener shipping by reducing fuel consumption and opportunity for implementation of renewable energy sources and alternative fuels. Competitive industry by opportunity to grow in size and volume, and also new personnel ashore by creating engaging and exciting maritime jobs. International Maritime Organization has recently defined 4 autonomy degrees for maritime autonomous surface ship. First degree is ship with automated processes and decision support, where seafarers are on board to operate and control shipboard system and functions. Degree 2 and 3 are remotely controlled ship from shore control center. Degree 2, in degree 2 ships, crew are still on board, ready to take action in need, but on the ship degree 3, there are no crew on board. Degree 4 is fully autonomous ship, which has operating system able to make decision and determine action by itself. Crucial part of every autonomous ship are guidance, navigation, and control system, also a variety of sensors that enable situational awareness. Reliable communication is also crucial. Depending on the size and usage, it can be internet connection, antenna, or satellite. Also, ground station, which also depending on size and usage, can be mobile device, laptop, another ship, or in the case of merchant autonomous vessel, it is a shore control center. On this picture here, we can see the relationship between autonomous vessel and shore control center. Autonomous vessel through satellite transmit data, and shore control center offers supervision and support. In this study, cost model is used. Ship costs are divided into capital costs, which are related to ship purchase, also operating costs related to crew number, wages, storage, insurance, and administration, and voyage costs, which depend on some typical route. These costs are related to fuel consumption, fuel price, speed, canal dues, port charges, and emission costs. Here we can see the equations used for calculating all costs. Daily operating costs are calculated in their relationship to ship size, and voyage costs are divided to fuel costs, port costs, and emission costs. In this study, emission costs are calculated for 4 different scenarios. First is no tax scenario. Second is current policy scenarios. Third is stated policy scenarios, and fourth is sustainable development scenario, which is required for global sustainable recovery. In this case study, container vessel is used. Costs are calculated for specific route from Amsterdam to Shanghai. Operating time of this ship is 320 days a year, and costs are calculated for the lifespan of 25 years. Firstly, costs are calculated for conventional container vessel, and then using research from European project Moonin, costs are calculated for autonomous container vessel. It is assumed that autonomous vessel is as safe as conventional one. Here we can see results. Here is a diagram of daily cost per container for all 4 scenarios. The first is for conventional, then next to it is for autonomous ship. It can be seen that in all 4 cases, autonomous ship has lower costs with most saving for sustainable development scenario. Here is sensitivity analysis also, which shows that fuel costs influence total costs the most. In conclusion, with stricter emission taxes scenario, the difference in cost between a conventional and autonomous vessel becomes more significant. Economies of scale occur in daily costs per container. Autonomous vessels have lower fuel consumption, resulting in lower fuel and emission costs. Operating costs decrease in autonomous shipping, and port and capital costs increase, but total costs are lower for autonomous vessel. Thank you for your attention, and I'm happy to answer your questions.
Thank you, Ivana. I'm gonna okay.
Mhm.
Thank you for